In this video, we're gonna make our own complete home automation system in which you'll not only be able to control 4 AC appliances but also able to control the speed of the fan using the capacitive dimming method, and everything will be working with internet and without internet. And not only that, you will be also able to control those appliances and the fan speed with the manual switches and manual fan regulator as well. So this is what we are going to make in this video. Let's get started. So for making this project, you'll require these all components whose lists and links are attached in the article, whose link you can find in the description of this video. I also attached the high quality connection diagram of all the components in that same article, so just refer that article while making this project. Now, due to a lot of connection in this project, it becomes very messy and very complicated if I just make this project in a general purpose PCB. So what I decided is I just designed my own custom PCB for this project and gave its order directly to GLC PCB. Now in GLC PCB, you can order your own custom PCBs in very simple steps. You just need to upload the Gerber file of the PCB, select the color masking if you want, and pay for your order. Using the FedEx courier service, you can get the delivery of the PCB after 10 or 15 days of ordering. So try ordering your own custom PCBs from GLC PCB to make your projects look neat, compact, and less complex. After getting the PCB, I just soldered all the components on it. For connecting the fan regulator, I soldered the wires with a female buck strip with a smaller pitch than usual, and connected the other side of wires to the fan regulator rotary switch. After that, I just removed all the circuit part of the commercial fan regulator and inserted a rotary switch inside it. Well, I have already soldered the male headers with that same small pitch on the PCB so that I can easily connect this rotary switch with our project like this. After soldering all the components, the project looks something like this. Neat and well arranged. Well, this time I'm not providing any free PCB along with my merchandise, rather I'm planning to sell the complete project. So just keep watching this video as I'll be talking about how I'm gonna sell this project at the end of the video. Now that was all about the hardware part of the project. Now let's just configure our Blynk application. For that, open up the Blynk application on your smartphone. Now if you don't have already, you can just download the Blynk app for your iOS or Android phone, whose link is mentioned in the description. After opening that, just click on New Project. Give a project name. I will name it as 4x1 feedback circuit. Device will be ESP32 for our project, and connection type is Wi-Fi. Just click on create project. So an authentication token will be sent to your registered email ID, which will be required at the time of programming of this project. Just click on OK for now. Okay, now just tap on the screen, and first of all, let's add a slider to control the speed of the fan. Okay, now just tap on that slider. Give a name if you want. Let's just name it as fan speed. Choose the pin for this as virtual pin V0, and speed will be from 0 to 4. Okay. Now here in the decimals, you just need to select the single hash. Okay. So that's it about the fan speed configuration. Click on OK. Now just tap on the screen and add a button here. Now tap on the button to configure it. Give button name. I'll name it as relay 1. Okay, its pin will be virtual pin V1 and the mode will be switch. Okay, that's it. So similarly, I'll be adding 3 more buttons at the virtual pin V2, V3 and V4 as our project can control up to 4 AC appliances. So that's it. I successfully added 3 more buttons at the virtual pin V2, V3 and V4 respectively. So that's it about the Blynk app configuration. Now let's just jump on to the last part of this project, and that's the coding. Okay, so here is the code used for our all-in-one home automation project. So let's just try to understand this code line by line. So first of all, the necessary library declaration which is mentioned here. So here you need to install just one library, that is the Blynk library. If you don't have already, you just need to go to Sketch, into Include Library, into Manage Libraries. Here just search for Blynk and just install this library. That's it. Moving ahead in the code, so here are the pin declaration of all the necessary input and output. So here are the pins for the fan regulator knob, that rotary switch. Here are the pin for the manual switches for turning on and off the appliances. Here are the pins for controlling the relays of appliances, and here are the pins for controlling the speed of the fan. Okay, so all the necessary pins are declared here. That's it. After that, here you have to provide the authentication token of your Blynk account, which must be sent to your registered email ID. You just need to copy the authentication token from here and just paste it here. That's it. After that, you need to provide the SID name and password of your Wi-Fi router, as this project do require internet connection while controlling it with the Blynk application. Well, it works without internet as well, so not an issue. After that, the necessary flags are declared just to make the logic for controlling the appliances with internet and without internet. Okay, let's just jump on to the setup part directly. Okay, and after that, I will be discussing all the above lines. Okay. So here are the necessary inputs and output declared. So, okay, all the pins are, all the switches and the rotary switch are declared as input, and all the relays are declared as an output. That's it. After that, we are beginning the serial communication with 9600 baud rate, establishing the Wi-Fi communication. Then here is a timer declared, which will be called after every 3 seconds. Now, what's the purpose of this timer? We'll discuss later on in this code itself. Okay. And after that, we're using this line, we are establishing the communication with the Blynk server. So that was all about the setup part of the code. Straight away, moving on to the loop part, we have a one if condition which checks the Wi-Fi connectivity. Okay, so if the Wi-Fi is not at all connected, or the ESP32 is not at all connected with the Wi-Fi router or the internet, it will just print as not connected. And in case it is connected, it will straight away print connected onto the serial monitor, and it will start all the Blynk related services. Okay, so this makes sense, right? If it is connected to internet, then only we need to run the Blynk services. If it is not connected, the Blynk services won't be running at all. Okay, so that's what is defined here in the if else condition. After that, we are just initializing the timer function. Now let's just see what's happening inside the timer function. So after every 3 seconds, we'll be calling a function called check Blynk. And let's move on to the check Blynk function and see what's happening inside it. So here's the check Blynk function, which checks the Blynk connectivity every 3 seconds. Okay, so if it is connected to the Blynk, it will just turn mode to 0, and in case it is not at all connected to the Blynk server, it will just change the mode to 1. That's all is happening inside the Blynk check Blynk function. It will be checked after every 3 seconds, like whether it is connected with the Blynk or not. Okay, so now let's just see what happens next. Okay, so here is the timer.run. After that, we are checking whether the mode is 0 or not. So here's the if condition, which says if mode is equal to 0. Now we all know that whenever the project or whenever the ESP32 board is connected with the Blynk server, the mode turns to 0. Okay, so in case the mode is equal to 0, we are calling the with internet function, and if the mode is equal to 1, that means it is not connected with the Blynk server, we are just calling the function called without internet. Okay, that's what is happening inside this. Now we are just left with having a look over what is inside the with internet function and what is inside the without internet function. Let's just check whenever the project is connected with internet, what happens. So it will be going inside this function. So what I did, I just divided the whole function into 2 different departments. One is for fan and one is for switches. Okay, as we have 2 kind of output devices in our project. For fan, what we are doing is we are just reading the status of the rotary switch. Okay, because in case of with internet mode, we need to control that appliances, maybe it's fan or the light, using the Blynk application as well as the manual switches. Okay, so for that reason, we need to check the manual switch status. Okay, so according to the status of that rotary switch, I'm just calling the function called speed1, speed2, speed3 according to at what position that rotary switch is. Okay, not only that, after just turning that fan to particular speed, I'm also sending feedback to the Blynk application. Okay, so in case of with internet, whenever we are controlling devices using the manual switches, it will definitely control that appliances, but along with controlling, it will be automatically sending the real-time feedback onto our Blynk application, and that's what is done with this particular line of code. Okay, so yeah, this is for speed 1, this is for speed 2, okay, and up to speed 4 and speed 0. Okay, so this was all about the fan speed control using the manual rotary switch. And here is the function for controlling the relay 1 or the appliances 1 using the switch 1, like manual switch 1. That's what is happening here. Okay, and along with controlling the switch, we are also sending the real-time feedback to the Blynk application as discussed earlier. So that's what happening inside the with internet function. Okay, but now the question is, we are able to control the appliances with internet using the manual switches and manual rotary switch, correct? But what about the Blynk application? How will we be able to control the appliances with the Blynk app? For that, you need to go in the top of the code. Okay, here is the function called Blynk write, and in the bracket we have written as V0. So this function will be responsible for whatever data coming from virtual pin V0 of your Blynk account. Okay, so at virtual pin V0 we have attached the fan slider, correct? So as soon as we send data of the fan slider, this function will be called, and according to the fan speed data received, maybe it's 0, 1, 2 up to 4, a particular speed, the respective speed function will be called. If we are sending data 0 from the virtual pin V0, it will be turning the fan speed to 0. That means it will turn off the fan. Okay, so this is how we can control the fan speed using the Blynk app. And accordingly, if we send the data from virtual pin V1, V2 up to V4, the respective function will be called. Okay, so if we take example of V1, whatever data received from the button, maybe it's 0 or 1, it will be just turning it on and off the relay attached to that particular pin, that is the R5. Okay, so this is how we can control it with the Blynk app as well. Okay, so we are familiar with how the things will be working with internet. Okay, now we are left with how the things will work when there is no internet connection. Let's have a look over it. So in case there is no internet, the mode will become 1, as we already discussed in the check Blynk function. Okay, so the code will go inside this else part and it will be calling the without internet function. Let's have a look what's inside the without internet function. So here is the without internet. Okay, here again I've divided this whole code into two parts. One is for fan and another is for switch. For switch, it is pretty simple, pretty straightforward. Whatever the status of the manual switch, just put that status to the relay as well. That means if the switch is turned on, just turn on the relay. If the switch is turned off, turn off the relay. So that's a simple line of code is used to do that task. Okay, so that's what happening in without internet mode for manual switches to control turn on and off the appliances. Now let's see how we'll be able to control the fan without internet. So here is for fan. So according to the data of that rotary switch, we are just calling the function. Now this is the same that we have discussed in the with internet function. The only difference here is we are not sending any feedback to the Blynk application. Okay, because without internet, it won't be able to communicate with the Blynk server. So there is no need of sending the feedback. So this is how you can control the fan speed without internet based upon whatever data is coming from the rotary switch. So that's pretty much it. But still, if you want to understand how this fan speed control actually working and how is the code written for this fan speed control, I'll suggest you to watch out this video, whose link is in the I button. And with this video, you'll be able to understand all the concepts of the capacitive fan dimming method. Okay, so do watch out that video if you want to understand this fan control concept in detail. So yeah, that's it about this coding part of the project. After that, you just need to select the right board, which is ESP32 Dev Kit V1. Okay, select the right port and hit the upload button. So we are done with configuring all the parts for this project. Now let's just see this project in action. After programming the ESP32 board, I first connected the main supply wires with the project, inserted the ESP32 onto the PCB and powered up the project. At first, it didn't get connected to the Blynk server, or rather the program was not at all running inside the ESP32 board. I was not able to send commands from the Blynk app as well. A big disappointment. So our team started debugging the whole project and finally we got to know the problem, and the problem was with GPIO12. Now GPIO12 was externally pulled high with a 10K resistor and it was used to get the reading of the rotary switch for fan speed control. Now what happened actually is the architecture of ESP board is made in such a way that some of the pins should not be pulled high or pulled low at the time of boot up. If it is so, the program won't be running inside the ESP32 board, and the GPIO12 was one of them. Okay, so what we did is we just scratched out the connection between the resistor R15 and GPIO12. After making that pin internally pulled up in the code, I uploaded that code again into my ESP32 board, and now when I powered up the project again, this time everything seems working like a charm. It got connected with the Blynk server and I was able to control the ESP32 board with the Blynk app. So now we are good to go with installing this project at our studio. So we opened up one of the switchboard at our studio for wiring connections. Be very careful while playing with the main supply. I'll suggest you to turn off the main switch before opening the switchboard. So we did the connection of the switches and the appliances with our PCB according to the connection diagram, which is attached in that same article whose link is in the description. So just take that image as a reference for connecting everything. After making the connections, we just closed the switchboard, turned on the main switch and powered up the project. Now let's play with our all-in-one home automation project. First, I tested the feedback from the manual switches to the Blynk app, and as you can see, I'm getting the real-time feedback of the buttons on the switchboard, and not only that, I'm even getting the feedback of our fan regulator. Now let's just try controlling the appliances. So as you can see, I am able to control the light either from that switch or from the Blynk app. The choice is mine. And the status of that switch is being updated on the app in real time. Now let's just try controlling the speed of the fan. So here as you can see, I'm able to control the speed of the fan with the Blynk app. Let's try it with the manual regulator. Yes, it works. So this was all with internet. Now let's just try turning off the router and see if it works or not. Yes, I'm able to control the lights with the switch quite smoothly. Let's check out our last combination, that are we able to control the fan speed without internet? Let's see. Amazing. We are able to do that as well. Hey, come on! This video do require a big thumbs up. Just go ahead, click that like button and just tell YouTube that this is the best home automation project video that you have ever watched on YouTube. Just do that right now. So this was all about my all-in-one home automation project, which is installed at techiesms Studio, and you can always see this project whenever you come to techiesms Studios. I hope you enjoyed this project and got to know something new from it. Do let me know in the comments regarding how was this project according to you, and will you be making this project for your home or office? Do let me know your feedback in the comments. So now if you guys are interested in purchasing this project, let me guide you. So this is the first time ever I'm trying to sell my project, and in this you'll be getting the completely shouldered project onto the PCB, where you just need to program the ESP32 board with your Wi-Fi credentials and the Blynk authentication token, and you are good to go to use that project. Okay, so what you need to do is you just need to click on the purchase link which is mentioned in the description of this video, which will be redirecting you to my website, that purchase page. Just fill out the details like your name, mobile number and the shipping address. Pay for that order. There are several payment options available, so you won't be finding any difficulty while purchasing this project. And that's it. You'll be receiving this completely shouldered project with all the components on that PCB. Just program that ESP32 board, whose code link is also mentioned in the article. And that's it. You're good to go to install that project and use it at your home and office. And if you purchase the project from techiesms, it will be definitely helping financially to me as well as my team for experimenting more cool stuffs at techiesms Studio. So do purchase it if you really like this project. That's it. Just ending this video here. Subscribe my channel if you haven't already, and now just wait for my next video and then explore, learn, share with me, techiesms.